Doctor. Now we will discuss our assignment 2. We choose Karawang Mosque located at Al-Mushiri Mosque as an example of a geometrical shape. Al-Mushiri Mosque is located at the Sultan Azlan Shah Campus, Universiti Pendidikan Sultan Idris. The Karawang Mosque is located within the Al-Mushiri Mosque at the Sultan Azlan Shah Campus of Universiti Pendidikan Sultan Idris. Its strategic position near Mosque College in the university make it easily accessible for everyone. The uses of Al-Mushiri Mosque provide a peaceful and welcoming space for Muslim students and staff to perform their daily prayers. This is crucial in fostering an environment of inclusivity and respect for individuals of diverse faiths, promoting a campus culture and embrace religious freedom and diversity. Additionally, the Al-Mushiri Mosque serves as a center for Islamic education. It hosts various educational events such as lectures, seminars and workshops on Islamic studies. These activities enrich the intellectual and cultural landscape of the university community, offering opportunity for a deeper understanding and appreciation of Islamic tradition and values. Next, the UC Karawang Mosque is renowned for its beautiful decorative element called Karawang, which can be seen at the entrance door of the prayer hall and other areas within the mosque. This intricate design enhances the mosque to overall beauty and elegance. The Karawang borders are found in arch, doorways, windows and minarets adding grandeur to the mosque. This detailed craftsmanship reflects a dedication to traditional Islamic art and design. The presence of Karawang borders in the mosque architecture shows a commitment to preserving and celebrating traditional Islamic art. By incorporating this intricate design, the mosque connects to Islamic cultural and artistic legacy, emphasizing values of beauty, symmetry and reverence. In summary, both the Karawang and Al-Mushiri Mosque play significant roles within the Universiti Pendidikan Sultan Idris. They not only provide space for prayer and reflection, but also promote Islamic art, education and cultural understanding.
Okay, next for the size of the Karawang in the mosque, for the height is 375 cm and for the base is 138 cm. For the diagram show the mosque of Al-Mushidin and the Karawang around the mosque. Okay, for 2.1 is the geometrical shapes. The Karawang mosque wall that we pick for our study outcomes in a variety of shapes, including rectangle, square, triangle, hexagon and octagon. Okay, for the first one is rectangle. A rectangle is a type of polygon that has its parallel sides equal to each other and all the four vertices are equal to 90 degrees. Hence, it is also called an equilateral quadrilateral. For the second one is square. Square is a regular quadrilateral which has all the four sides of equal length and all four angles are also equals. The angles of the square are at the right angle or equal to the 90 degrees. Third one is triangle. Triangle is a closed two-dimensional shape. It is a three-side polygon. All sides are made from straight lines. The point where two straight lines join is the vertex. Hence, the triangle has three vertices. Each vertex forms an angle. For the fourth one, a hexagon. Hexagon is defined as a closed 2D shape that is made up 6 straight lines. It is a 6-side polygon, which means it has side polygon, which means it has side 6-sided, 6 vertices and 6 interior angles. For the last one is octagon. In geometry, an octagon is an 8-pointed star polygon. In general, an octagon is an self-intersecting octagon with 8-sided polygon. The regular octagon is labeled by the scalify symbol, which means an 8-side star connected by every third point.
Hello everyone, my name is Nurul Adibafani Mitroslan and I am the one that will explain about the geometrical concept of the object geometrical shape and measurement. The first one, object shape, is rectangle shape. I'm sure you already know about the length and width of the object. Therefore, we can conclude that the length is the altitude of the height, which is 375 cm, and the width will be the base, which is 138 cm. Next, we also know that rectangle is a parallelogram that has right angle. Thus, the angle of each corner is 90 degrees. Perimeter of a rectangle is given by the multiplication of the number of sides and the sum of the length of the side. So, we can get the perimeter 1026 cm. The area of the rectangle is given by the multiplication of the bases and the length, and it will be 51,750 cm square. To add on, a rectangle has the opposite side that is parallel and it consists of two diagonals that are congruent. The the length of this diagonal can be calculated using the Pythagorean theorem. Next, the second shape is square shape. Square shape is the shape that have four sides of equal length. The measurement of the length of the square is 8 cm. The angle of the square is a right angle. Therefore, each corner having an angle of 90 degrees. The square is highly symmetrical and uniform shape. Perimeter of a square is given by the multiplication of the number of sides, which is 4, and the length of the side. Thus, the perimeter of the square will be equal to 32 cm. The area is given by the multiplication of the side of the square, which the area of the square will be equal to 64 cm square. The square has two congruent diagonals that intersect at right angles and bisect each other. Thus, at the opposite side must be parallel to each other. The other shape that we found in Karawang border is triangle. The triangle here is an isosceles triangle. Therefore, the legs of the triangle have an equal measure of length, which is 7 cm, and the base will be 10 cm. The isosceles triangle theorem states that if the side of opposite those angles are congruent, then those two angles of a triangle will be equal. Therefore, the angle for bases, which is the angle of B and C, can be found using the trigonometry formula, and the angle of each corner is equal to 44 degrees. To find the vertex angle is by the sum of the measure of the interior angle. So, the angle of A will be equal to 92 degrees. Next, the perimeter of the triangle is given by the sum of all the sides. Thus, it is equal to 24 cm. Since it is an isosceles triangle, the Heron's formula will be used in order to find the area. Therefore, the area is equal to 24.49 cm square. The next shape is hexagon shape. To be specific, it is an irregular hexagon. Thus, the length of the side will be 6 cm and 8 cm respectively. In order to find the angles of the area, a helping line will be added to get the shapes of isosceles trapezoid. Isosceles trapezoid is a trapezoid where the two legs are congruent. Thus, the base angle will be equal to each other. The perimeter of the shape is 44 cm. To find the area of an irregular hexagon can be more complex than a regular hexagon. Therefore, we can conclude that the method such as breaking the hexagon into trapezoid can be necessary. So, first thing first, we need to find the area of trapezoid, which is 40.5 cm square. After that, we can find the total area of the irregular hexagon by the addition of the area of trapezoid, and it is equal to 81 cm square. And the last one is the octagram shape. Octagram has all sides that are the same length and all the interior angles are the same angle. For our information, the length can be divided into two lengths, which is by length, which equal to 3.51 cm, and the octagon edge length, which is equal to 4.97 cm. An octagram consists of 8 side polygons. The sum of the interior angle is 1080 degrees. Therefore, each angle of the corner will be equal to 135 degrees. The perimeter of the octagram is the multiplication of the side, and it is equal to 48 cm. And lastly, the area of the octagram is 69.88 cm square.
Today I will talk about transformation. There are two, which is reflection and also rotation. Firstly, reflection. Reflection is when an object undergo reflection, it is flipped over an imaginary line called the line of reflection, creating a mirror image of the original object. This line can be vertical, horizontal, or slanted. Each point on the original figure is mapped to a point on the reflected figure such that the distance from the original point to the line of reflection is equal to the distance from the reflected point to the line. Points lying on the line of reflection remain stationary, acting as fixed points. The reflected figure maintains the same end shape as the original, but its orientation is reversed as it seems in a mirror. Secondly, rotation. Rotation involves revolving a figure around a fixed point called the center of rotation, reorienting the figure while keeping its size and shape unchanged. The distance from the center to any point on the shape remains constant, resulting in a new figure called the image, which is congruent to the original. If the angle of rotation is positive, the figure rotates counterclockwise. If negative, it rotates clockwise. This convention aligns with the unit circle in coordination geometry. Rotation can occur around any point, not just the origin, allowing for diverse transformation while preserving the figure's congruence. Figure 2.3.1.1 illustrates the various motifs we studied, which include polygon shapes like square, irregular hexagon, trapezoid, and octagrams. In this motif, we explore transformations such as reflection and rotation. Reflection involves flipping the shapes over a line,
of reflection to create a mirror image, while rotation involves turning the shape around a fixed point by a certain angle. Figure 2.3.1.2 and 2.3.1.3 illustrate the reflection of a square and an irregular hexagon over the x-axis. This figure clearly shows that the reflected images are at the same distance from the x-axis as the original shapes. This demonstrates that the x-axis can function as a line of symmetry, which it acts as a horizontal mirror line. Consequently, the shapes reflected across this horizontal line retain their original size and shape. Figure 2.3.1.4 illustrates the reflection of a trapezoid shape across the y-axis. From this diagram, it's evident that the reflected image maintains an equal distance from the original. This confirms that the y-axis serves as a vertical line of symmetry, ensuring that the reflected shape retains its original dimensions and form. A rotation is a type of transformation that involves rotating each point in a figure by a specific number of degrees around a given point. It's important to note that on a unit cycle, the degree movement occurs in a counterclockwise direction, corresponding to the numbering of the quadrant 1, 2, 3, 4. However, if we reverse the direction and move from 4, 3, 2, 1, the rotation will appear clockwise. Based on the occupying figures and diagram, it is evident that the shapes rotate in the clockwise direction. In figure 2.3.1.5, the direction is clockwise as it moves from quadrant 2 to quadrant 1, while in figure 2.3.1.6, the direction is also clockwise, transitioning from quadrant 2 to quadrant 4. Similarly, figure 2.3.1.7 follows a clockwise path progressing from quadrant 2 to quadrant 4. The pattern transformation is reflection. There are various shape reflection in this pattern, including reflection of squares, irregular hexagon, trapezoid, and octagons. In figure 2.3.2.1, a reflection over the y-axis is depicted. As shown in the figure, the pattern is reflected across the vertical line, the y-axis, creating a line of symmetry. Meanwhile, figure 2.3.2.2 displays a reflection of a square across the x-axis. In this figure, the square is reflected across the horizontal line, the x-axis, creating a line of symmetry.
To summarize the topics covered in parts A and B of our investigation, we have chosen the Karawang Mosque Wall as an example that meets the criteria for geometrical shapes. Karawang is a term originating from Indonesia, referring to a traditional pattern of motif. The intricate geometry and arabesque designs contribute to the artistic and cultural significance of the mosque. The primary objective of the mosque is to honor and preserve traditional Islamic architecture and art. The dedication of the Muslim community to maintaining and transferring artistic and cultural heritage is evident in the use of Karawang borders. We selected the Karawang Mosque Wall for our assignment because it features a variety of shapes including rectangles, squares, triangles, hexagon, and octagons. The ornamentation's two-dimensional forms correspond to the shapes we investigate in this structure. Transformations can take many forms, including translation, reflection, rotation, and dilation, each with its own distinct properties. In particular, rotation and reflection exemplify the principle of transformation observed in the motif and patterns of the item we have chosen. So, we can conclude that our task provided us with valuable understanding and experiences. Karawang patterns are known for their intricate details and symmetrical designs, often found in various of arts and crafts. For instance, Karawang pattern can be seen engraved into wooden furniture and doors, as well as illustrated by the Karawang Mosque Hall. These patterns hold significant cultural importance, which are deeply rooted in local traditions and heritage. Karawang patterns also have a strong connection to geometry, particularly through the concept of transformation. They can be used to introduce geometrical transformations such as translation, rotation, and reflections. As students, we can examine of how these patterns change under different transformation, which help to make geometry more understandable and applicable. Moreover, Karawang pattern also highlight the relationship between geometry and real-life application in art and design. These patterns are commonly used in traditional textile, wood carving, pottery, and even modern graphic design. This indicates to us of how geometry serves as a bridge between art and mathematics, enriching our understanding of both fields. So that's all from our group. Thank you for watching.